Hello my dear students, in a previous class we have discussed some problems and we have given one question as a example for you to try among yourself. So let us go ahead with that. First we'll solve this problem and next we'll go ahead with the next upcoming problems which is related to your competitive questions, right? So what is the first question here? Find the velocity for the particle in a simple harmonic motion. That means particle executing the simple harmonic motion if initially the particle is at the a by root 2 of origin and moving initially in a positive x direction. So before solving directly with the equation here, let us go ahead with the how the particle execute the simple harmonic motion here. So if it would be a mean position, x will be 0 here at t is equal to 0 and the velocity will be maximum. So why we have to write this one means velocity only we are going to find out here at velocity which part it is maximum. So this is the positive x direction here, right? So when it is executing simple harmonic motion, right, it will move towards the extreme position of positive direction. Similarly, it will comes to the mean position and it will not stop here. This form we already know here. It will goes to the another extreme position, that is x is equal to negative here, and it will comes to its position where it has started the mean position. This was the function we know, and extreme position velocity will be 0. 0 in the sense what it is almost negligible. Whether extreme position is a positive or the negative direction, it will be 0 only. So it will be 0 only here. Next, what is the question meaning here? We need to find the velocity for the particle executing the simple harmonic motion if initially particle is at the a by root 2. Initially, if the particle is at the mean position, x is equal to 0, but it is saying that particle is at the a by root 2. So if x would be a here, its next position will be, we are assuming that here it is. That means x is equal to a by root 2. You can take here also, wherever you can take, means after the extreme position also or before reaching to extreme position, whichever you can take, but it is given. So x is given here. We need to find out the velocity for this position it is. So that is the question here. We have a velocity that is of next form will go. Let us go ahead with that. X, we have this form at this position. X is equal to what here? A sine omega t plus phi. So this form we have general equation of a particle executing simple harmonic motion at extreme position, or the displacement from the mean position it is given. So x is given here, that is of a by root 2 here, right? Next we'll substitute this form here. A by root 2 is equal to a of sine omega t plus phi it is. So a get cancels, remains with 1 by root 2. I think you have been tried this. Those who have not tried, you just cross check what you are doing, what I am doing, so which is correct. So that is cross verification is very important here. So a by a got cancelled here, remains with 1 by root 2 is equal to sine omega t plus phi here, right? So next form it is, if initially I forgot to, suddenly I have erased here. Let me go ahead with the a by root 2 here, At that time t is equal to 0, because this is the initial position of a particle where it is started executing the simple harmonic motion, right? So look at this part. Velocity when it is moving in a positive direction, right? So its velocity maximum to at the mean position to the extreme position, or x is equal to a by root 2. For to reach this point, velocity will be maximum to velocity will be 0 it is, and it will not stop here. So it will comes to mean position, right? And it will not stop to the mean position again, it will go towards the negative extremities, maybe a minus root 2 it is. So once it is coming back means it is towards the negative. So when velocity is moving from extreme to the mean position, from 0 to maximum velocity it is, so velocity will be taken it as a negative. We'll come to the next part there. So 5 will be, come to the part of sine inverse of 1 by root 2 is equal to omega t plus 5. We can write it. So sine inverse of 1 by 2 we can write here 45 degree, as t is equal to 0 here at the initially. We got it as this will be 0 and 5. 5 will be either 45 degree, right? I mean 5 it is given as a 45 degree it is. Let us go ahead with the allied angles here. So let us go ahead with the allied angles. So this is the 0, 90, 180, 270, again 360 here. So 5 is at this point, 45 degree means it is a positive, means body is moving in a positive x direction it is. And here in this first quadrant all are positive here. Here sine is positive, tan and cos is positive. So we have a possibilities of second quadrant also, because if it have taken the mean position here, it is moving in this direction and it is moving in this direction also. Simple harmonic motion, to and fro motion. And which of the 5 will be possibilities it is, so that we have to cross check. I mean it may be 135 degree also, means less than 180 degree it is. We can also cross check with the 180 degree minus 45 degree here. So will you get it or what? Let us cross check. So 180, 45 degree. If you cancel it, you will get the same 135 degree. Is it correct or not? Let us go ahead. So 5, 5. So 8, 8 minus 5 here. That is of 4. So 8 minus 5, it is a 3. Again 135 degree. So we are getting 135 degree. That means 180 minus theta is also possible. This is also possible. That means 135 is also possible if you go ahead with the 135 degree also, right? So this is possible. Then we'll cross check with the velocity. It is said to be moving from a positive x direction towards the maximum velocity at the mean position. So it is moving from extreme position, means from here to here, from here to here it will move. That means velocity will be negative here, and that indicates here velocity is going to be greater than 0, because once it is crossing mean position, velocity will be more than maximum here. Means once it is crossing from extreme position at the x is equal to a by root 2, from this point to this here, velocity started increasing from 0 to maximum it is. So this indicates what here, at this point at t is equal to 0 initially, at x is equal to a by root 2, right? Velocity will be maximum. It is velocity must be maximum. We have velocity. What is that? V a omega cos omega t plus phi. So we have now x is equal to what? We have to go ahead with the derivation of displacement, then we'll get the velocity of this. So this will be negative. Moving next, after the mean position, it was trying to move towards the negative direction. It is. So for that reason, you should go ahead with the velocity as a negative sign here. So v will be negative sign. So v is equal to minus a omega cos omega t plus phi it is. Next, as we know, we have to find out the velocity here. Minus a omega cos is 0 here, phi. So remains with minus a omega cos phi here. As we know, this part, omega part, or this cos phi must be greater than 0. It is as this condition. So where v is equal to minus a omega cos phi. So this part cos phi should be greater than 0. Greater than 0 it is. Now we'll have an option of 345 only. 135 degree only, because there is a possibilities of checking negative also here, because only sign is positive here. In second quadrant, cos is negative. So for that reason, second part is a perfect one. As we move towards cos phi, it can also be written as a 3 pi by 4 it is. Cos 135 degrees can be written as a 3 pi by 4, and negative sign indicates it as particle is moving positive in direction from the mean position, and from the a by root 2 it is moving towards mean position, and it will not stick there in the mean position. It is moving towards the negative direction. For that reason, velocity will be negative here. V is equal to minus. So finally we conclude what is the velocity here? Minus a omega cos omega t plus 3 pi by 4. So this is the velocity of the particle executing simple harmonic motion at the point x is equal to a by root 2, initially moving in a positive x direction. So this is about the solution of the question, what we have discussed and what we have given as a task, one of the chance to solve the problem in the previous class. So let us move ahead with along with this some other very interesting. So in this next problem, just like a competitive test, it is asked in a KCET NEET question also in the previous year, that is of 2004 it is. So let us go ahead with the question. The equation of motion of a simple harmonic motion is given. Four options are given here. So we need to cross check which one will prescribes the equation of motion of a particle in simple harmonic motion. So either dA square x by dt square is equal to minus omega square x minus omega square t minus omega x and minus omega b. So let us go ahead with the solution. Which will be the correct solution of this question? It's given in the four option there. As we know, we have a acceleration minus omega square x it is. So acceleration can be written as a dv by dt it is. So v can also be written as a dx by dt here. So as we move with the acceleration d by dt of v place, I will introduce here, that is of dx by dt. So we'll get it as a d square x by dt square here. So if you substitute here dx by dt square, d square x by dt square, that remains with minus omega square x it is. So d square x by dt square, if it comes here, that is of omega square x is equal to 0. So this part we know it is nothing but the differential equation of a acceleration of a particle when it is executing the simple harmonic motion. So which option is there in the given problem? So minus omega square x. So this is the perfect answer for the simple harmonic motion if particle is executing. So that equation will give you of its acceleration here. So this is the first option will be the correct option for the given problem here. So like this, we'll go ahead with some other problems. So let's just go ahead with the next problem here. If the simple harmonic motion is represented by d square x by dt square plus of alpha x is equal to 0, its time period is what? So four options are given here, that is of pi 2 pi root of alpha, 2 pi alpha, 2 pi by root alpha, that is of pi pi, 2 pi by alpha it is. So let us go ahead with the solution of this problem. So differential, this is a simple harmonic motion it is given, that is of d square x by dt square plus of alpha x is equal to 0. This is a simple harmonic motion of a particle. It is given here. Only thing that its a time period is how much. So we have a differential equation of acceleration just now we have discussed in the previous problem here, that is of, if you are getting confusion you can go ahead with the original form of acceleration of particle here. That's we can write it here dx by dt square, that is of minus omega square x it is. So d square x by dt square, so it's not catching the camera. So d square x by dt square plus of omega square x is equal to 0. So this is the differential equation of acceleration here for particle executing simple harmonic motion. So both are similar to each other, both part. If you consider any particle which is executing simple harmonic motion, this part will be is going to be observed in that. This is nothing but the acceleration of particle. Same the simple harmonic motion it is given in the equation, same part it is. So both are there in similar. Only thing that it is omega square, it is with respect to this expression, that is of alpha here. So if you go ahead with the omega here, root of alpha. So we have a time period t is equal to 2 pi by omega here, that is of 2 pi by omega is what here, root of alpha. So the time period of a particle executing simple harmonic motion. So in this, it will be the option here, option C will be the correct answer for the given question here. So like this, we'll move ahead with the next problem, that is of very, if you feel it is very simple, but once you understand the problem thoroughly, in a short time we are going to solve the problem here. So like this, we'll go for the next problems. In the next problem, which of the following relationship between the acceleration and the displacement x of the particle A executing the simple harmonic motion? And so the sentence is there. I thought it is not needed to write it in the board here. So once again, I'll read it. Which of the following relationship between the acceleration and the displacement x here of a particle, so of a particle executing the simple harmonic motions. So options are given here. Executing simple harmonic motion, right? It's acceleration and it's a displacement here. So relationship, you have to go ahead with that. Option is given, A is equal to x square here, B is equal to A is equal to minus 2x square, C is equal to, C option is A is equal to 2x, D option is A is equal to minus 2x. here. So by seeing this problem, you feel that it is very easy. But let us cross check which will be the correct form, which is executing simple harmonic motion, how the displacement and acceleration are related to each other. So let us go ahead with this solution. We have, so solution of this problem, we have acceleration that is of minus omega square x it is. So compare this part with the 4 option here. So minus omega square x is there. This is not possible because it is positive. So next, a is equal to minus omega square x. Minus x is there, omega is there, but not square. X square is there, that is also wrong here. So a is equal to 2x. No, it is not holds good. Finally, that is the last option, a is equal to minus 2x. So let us cross check. So a is equal to minus 2x. So omega square is equal to 2 here. So that seems here, same form it is like a acceleration of a particle executing the simple harmonic motion. So option will be 4 here. So like this, you have one more problem that is of particle executing the simple harmonic motion, amplitude with the amplitude is given here, amplitude and the angular frequency. Angular frequency is nothing but the omega here. The ratio of a maximum acceleration to the maximum velocity of a particle. So they are going to asking here particle executing the simple harmonic motion, amplitude and the angular frequency relation, the ratio of maximum acceleration, right, and the maximum velocity. So what will be the condition here? That only they are going to ask here, but the option is given. Particle, simple it is. Question itself is a simple, but it is in a statement, so I have not written here. Particle executing the simple harmonic motion with the amplitude. I'll draw the diagram. So executing simple harmonic motion with the amplitude here and omega angular frequency that is of 2 pi by t. Having this one, so acceleration will be maximum at extreme position it is. Velocity will be maximum at the mean position. So ratio of acceleration and velocity for that particle we need to find out here. So that means we'll go ahead with the maximum velocity. So maximum velocity where it is at the mean position. That means we have v is equal to a omega cos omega t plus phi it is, right? So maximum in the sense what here, phi will be x is equal to 0 means x is equal to 0 at the time period t is equal to 0 it is. That means this whole part will be remains 0 here. So a omega cos phi it is v, when cos will be, when phi will be equal to 0 degree, 0 in the sense what, at the mean position. So v will be a omega here, cos 0 is 1. So velocity is maximum at the mean position. This we got it here. And acceleration is what here, a omega square minus a omega square sine omega t plus phi it is. This equation we know already here. That means at the mean position only, let us cross check, or the and omega t, this part will be 0 remains with a omega square sine phi. Sine phi is there here. Sine phi when it will be maximum at sine 90 degree. So at 90 degree of a sine part, it will be equal to 1 here. That means acceleration will be maximum at minus a omega square. So this is the part here, maximum acceleration. What we got it? We have got it here minus a omega square here, but the modulus of this we can take it as a omega square here. Maximum acceleration a omega square, maximum velocity what it is, a omega here. So a cancels, omega cancels, remains with the omega. So option is given here. Sorry, I have not given the options before. A is a omega, a capital E. Second option omega square a. Third option omega. Last option omega square by a. So by this conclusion we got the answer is omega here. I'll repeat the question once again. A particle executing the simple harmonic motion having the amplitude and the angular frequency, its maximum acceleration to the ratio of maximum velocity we need to find out, because relation it is given and the ratio of maximum acceleration and the maximum velocity we need to find out. We know that maximum acceleration is at the extreme position, right? And maximum velocity will be at the mean position. We have that equation. Velocity is a omega cos omega t plus phi. It will be maximum when cos phi is equal to 1. When will be the cos phi is equal to 1? Cos 0. When phi is equal to 0 it is. So when phi is equal to 0 here, at the just to begin to start the simple harmonic motion from the mean position. So at that time t is equal to 0 and the cos will be the 0. It is not making any angle here. So that's why a omega is a maximum velocity for the particle executing simple harmonic motion at the mean position. Once you go ahead with the maximum acceleration, it will be at the extreme position, as we have equation a is equal to minus a omega square of sine omega t plus phi here. So sine phi, when it will be maximum, at the sine 90 degree. So 90 phi will be equal to what it is. So 90 degree, or else we can say that pi by 2 it is. So that means a acceleration is equal to minus omega square a it is. When you go ahead with the modulus of the acceleration, because this minus a omega square will be remains same whether it is a negative direction or the positive direction here. So that's why we are taking the modulus of a to just to remove the negative sign. Modulus of a will be equal to a omega square by a omega square here. Then the given ratio of maximum acceleration and the maximum velocity, that is of a omega square by a omega for the maximum velocity here. So omega cancels, a cancels, amplitude cancels, angular frequencies cancels here, remains with the totally only one angular frequency here. So this is the given answer, and in that 4 option omega is there as the third position. So like this you are going to enjoy the problems, and you are getting enthusiasm to solve the next problems also. So in that next problem we have displacement, and we are going to find out the displacement in a given time period and the velocity also, or else maybe they are giving amplitude. So let us go ahead. If a displacement of a particle executing simple harmonic motion, so you should not get any problem here, because saying orally is difficult, and observing in the board here, the displacement of a particle is given here, that is of x is equal to 3 sine 2 pi t plus pi by 4. So this is given here, where x is the displacement here, I mean in terms of meter, where x is in meter here, right? And its t is in seconds. T is in seconds. It's given the amplitude and the maximum speed of the particles. So we need to find out the amplitude and the maximum speed. Maximum speed is nothing but the velocity of a particle only. So of a particle. Options are given. So let us go ahead with the first option is 3 meter. First we need to find out the amplitude, then we need to find out the maximum speed. So 3 meter and 2 pi meter per second. The first option it is, and the second option is 3 meter 4 pi meter per second. Third option is 3 meter 6 pi meter per second. Fourth option is 3 meter 8 pi meter per second. So in this 4 option, any one is the perfect solution answer here. Let us go ahead with the solution here. So we had given, I mean to say that in that question it is given here, displacement of a particle x is equal to 3 sine 2 pi plus 2 pi t plus pi by 4 it is. We have a displacement of particle equation. General equation of particle is a sine omega t plus 5 it is. So by this it look like a same general equation here. That means amplitude, I'm going to write it here 3. So we got it first part in terms of meter it is, that is a amplitude is equal to 3 meter. First part we got it. Next one we need to find out the maximum speed here. In this maximum speed we have to go ahead here. Omega is equal to, with respect to this, 2 pi. We have a time period t is equal to 2 pi by omega here, right? So as we move here, t is equal to 2 pi omega is equal to 2 pi here, the velocity and the maximum velocity. So it's going to be cancelled here. It doesn't give any meaning. So let us go ahead with the next part, that is maximum velocity or maximum speed. When it will be, just now we have discussed, that is of a omega here. A omega, maximum velocity, maximum speed it is. A is what here? 3 omega is of 2 pi. So that means 6 pi velocity in terms of seconds here. This is nothing but the time period also in terms of second only, because omega relation is 2 pi by t only. Relation I'm telling here. So in terms of seconds here, amplitude is in meter, omega in terms of second here, so that is of 6 pi meter per second. So omega is 3 meter, velocity is 6 pi. In this, which is the correct option here? Third option is a correct one, because the amplitude is 8 meter is given, and the velocity, maximum velocity or maximum speed of a particle executing simple harmonic motion, that is of 6 pi meter per second. So this is about the some questions. We'll discuss the some more questions in the next upcoming classes here.